Hello, YouTube. Okay, we're back. It's Friday evening. We're going to do another lightning round about the math that's on the SHSAT and many other tests. Again, I'm Greg from GregsTutoringNYC at gmail.com. If you haven't yet, please like this video, subscribe to my channel, and of course share it. There's tons of material I've posted already over months now, and covering grade 7 and grade 8. Which is the basis of a lot of the material, Common Core things, as well as SHSAT specific material, and for other tests. This is applicable for the ISEE, it's applicable for the Hunter test, it's applicable for the SSAT, even the PSAT, and even some of the SAT things. There's a whole bunch of tests. They're all intertwined and connected here. That some of the fundamental materials universal across the board. All right, so what we're doing in these rounds is we're just picking little snippets of mathematical things. It could just be a concept by itself, or it could just be a small example. For instance, yesterday we did a bunch of examples pertaining to square root and other things. Again, if you guys have questions, you can ask in the stream. You could also email me, and I could perhaps add it into a future stream like this or a larger one. All right, so how about x versus minus x? Can't really get simpler than this. All right, so how about we run through some choices? X is always larger. I put greater than, or meaning this, minus x, always larger. C is their equal, and D means we don't know. So which of those four scenarios seems like it would make the most sense? The x versus minus x. Hey, hi, how you doing? Right, so in a scenario like this, we could just plug in values. I think everybody knows what a positive number is and a negative number. So we can plug in positive and negative numbers to see what happens. Okay, and of course there's always 0. All right, looks like my stream's going good. So if we have, say, if x is equal to 1, and if we kind of make a chart of x versus minus x. Right? So if x is 1, this is 1, this is minus 1. If x is 0, they're both equal. And if x is something like minus 1, then this becomes minus 1, and this becomes 1. So we can see that if we don't really think this through, we have them here being equal. Here this is larger than that. And here this is larger than that. And when you're in the middle of a high-stake test, taking, ripping apart a word problem or something like that, it's easy to start getting confused about some of the fundamental concepts. And that's true of all these little snippets we're using here. So this is just total easy peasy. You should probably know this for years now, but we're just stating it mathematically because a lot of the word questions, that's how they're presented. And again, these could be sub-pieces, so it's not so much that the SHSAT's going to ask a question directly about this, although some do. I believe this is a question on the ISEE, so some tests might add it specifically or do something like that. All right, so it's just something to be aware of. Here's another one that comes up in a lot of tests. So we buy something for $99. Okay, tax is 10%. Then there's a discount of 10%. Do these cancel each other out and we end up with $99 back again? Or not? This comes up in a lot of tests, really from grade 5 onward. And it sounds like a totally simple problem, and again, a lot of kids will get this wrong. And it may not be as obvious as this, but sometimes it will be as obvious as this. So what do you guys think of that? But let's run through the numbers. If the tax is 10%, then that's $990, I believe, right? So if we add that, do that over here, 99 plus 990, we get 98.1, we get 108.90. Okay, if we take a discount now of 10%, we're going to take away from that $10.89. So we get 108.92 minus 10.89. This is pretty ugly here, so let's see if I do this right. 30, that's 9. So we get 8. What did I do here? 98.03, I believe. So it turns out the numbers are not right. So it doesn't bring you back the original number. So remember, if you have a percentage removed and a percentage added, or vice versa, they don't cancel each other. You actually have to do the numbers. Because we can see we get $108.90. Okay, even if I did a small error in here, and I believe I did, the truth of the matter is you just can't do that. So you have to be careful with stuff like that. Yeah, my error is here. I wrote a 2. There should be a 0. So we get 1 here. Okay. Okay, here's a good one. How much percent is, what I had that? 3 over 125 to the 1/3. How much percent is 3 over 125 to the 1/3? What does that even mean? Okay, a lot of you guys have seen something like 3 over 125. What does it mean to say 125 to the 1/3? This means to cube root. A lot of you familiar with something like this. 16. There's an implicit 2 here. We can also write this with a 3. Get something like 27 here. It would be 3 times 3 times 3. So the cube root of that would be 3. 3 times 3 is 9, times 3 is 27. So we're asking the same thing about this. What's the cube root? So this means to the 3rd. Same with this 16 to the 1/2. Means the square root of 16. Okay? So 3 over 125 to the 1/3 means 3 over 5. Because 5 times 5 times 5, get 25 times 5 equals 125. And then it's asking what is the percent. So that's equal to 60 over 100. Multiply this by 20, this by 20. We could have also done 5 divided goes into 3.00 and gotten 0.6 there. That was the same way. So the answer to this is 60%. So how much percent is in 3 over 125 to the 1/3? 60%. So I tried to add a little second question to it. So that first of all, you understand what to the power an exponent of 1/3 meant, and then add the other thing on. Okay, let me make sure we're still going live here. Yes, we are. So again, we're just going to do a few of these. Actually, let's do a second one of these, because this little problems like this can come up while you're solving larger problems. Let me do another one. What does 2 to the minus 2 mean? A lot of people have bent out of shape about not only does what a fractional exponent mean, but what does a negative exponent mean? And this is an identity. It means 1 over this same thing to the positive. So if it's 2 to the minus 2, so something like 2 to the minus 3 equals 1 over 2 to the third. So what you do is you make it the denominator, and you make the exponent positive. So this would be equal to 1/4. And if I ask the same kind of question, how much percent is this? It's going to be 25%. It's a quarter. All right? You need to get fluent and stuff like this. Again, guys, if you're not following things like this, these are terribly simple notions. You need to go back and review these concepts. Review exponents. Review fractional exponents. Review negative exponents. Review, what's the thing I just did? Review interest and how percentages work and so on the other one there. Okay? Because if you can't get the little problems like this, you're not going to get the super problem, so to speak. All right, let's try another one. Let's see if I have any on a different topic here. All right, let me see here. I have a bunch of stuff written on the file. And again, we're only going to go for 5 more minutes or so on here. Yeah, this one comes up in a lot of tests as well, since grade 5 as well. And it's going to be on the SHSAT in one form or the other. It's also on the integrated algebra test. It's on grade 5 test, the grade 6 test, the grade 7 test, the grade 8 test. Okay, so so let's say we have a set of numbers 2, 4, 6, 8, 0, and 0. Okay, the first question is, what is the range of this? What is the range of this set of numbers? And normally they're not written in order. I wrote them in order. Actually, they're not, because I have a 0. So the first thing we need to do when we have sets is put them in order. Numerical order. By the way, notions like range come up often. It might be based on a histogram table or something like that, where you're being asked for the range. The concept is still the same. So whether you're given a set of numbers or you're given an illustration, could also be in a pie chart, because there's a zillion choices here that they could present to you. It could also be in a word problem, where they're saying it's even numbers counting up to something or whatever the case may be, from 2 to 8. I added zeros there as well, right? So the range is taking the max number minus the min number. So basically we have 8 minus 0 equals 8. That's all they're asking for, the range. What is the span of the list of numbers? That's one reason why you're putting them in order. Okay. The next question that may come about, and the SHSAT's not going to ask you some of these directly, but you may have to use them. It might say the mean is something, or the mean squared of this set of numbers, something happens with it, okay? So what is the mean of this set of numbers? Okay, and by the mean is the same as the average. So we get the sum of the numbers over the number of numbers. It's the same thing you've been doing for years. Again, these don't come up often commonly, but these are notions you have to figure out. So we're going to get, let's see, what do we have? 6 plus 4 is 10, and 2 plus 8 is 10. So we get 20 over 6. And I can reduce that. We get 10 over 3, and that's equal to 3 1/3. Or if you want, it's equal to 3.3, going on like that. Okay? So that's the mean and the average. What is the mode? The mode is the most frequent number that comes up. So in this case, there's 2 zeros, so the mode is 0. And the median is the midpoint number. So in the list, if we cross off from one side, get rid of the 0, get rid of the 8, get rid of the 0, get rid of the 6. We end up with 2 and 4. When there's that, what we do is we average them. So we're going to get 6 over 2 equals 3. So the median ends up being 3. Once there's not a middle number, if there's not a middle number, if there was, we just take the middle number. If there's not, we actually do get the average of the two middle numbers. Okay? So if I was to have, for instance, 1, 3, 5, and 7, okay, the range of that is 7 minus 1. That's 6. Okay? The mean of that is, we got 8, 9, we got 16 divided by 4 equals 4. The mode is the most frequent number. It turns out there's no node frequent number. So there's no mode. There's no mode in the sample set. And the median, we're going to go 1, and we have the 2 of these, so the median is 4. The median is also 4. In this case, the mode and the median are the same. And by the way, if I had something like 1, 1, 3, 3, then there's 2 modes. Mode of 1 and 3. And this is called bimodal. So when you're being given questions, you may not have heard terminology. Remember, bi is like bicycle. Biped, we're bipeds. We have 2 feet, stuff like that. So what has 2 modes? Could also be trimodal then. In some cases, the data set might have a bunch of numbers that are all together that way. All right, so this part isn't hard, but it's a section a lot of kids will lose points. You're just throwing points away by not memorizing and remembering all these kind of things like that. All right, let me do another one to kind of hit home the square roots and the fractions and all this other stuff. If I have minus 1/3, where did I have that written down? To the minus 2. So we're going to try to more or less combine some of the stuff we talked about before. What is that equal to? So we talked about before that x to the minus 2 meant 1 over x squared. So that means we're taking this whole thing and we're making it 1 over minus 1/3 squared, and that whole thing minus. Okay, so that's equal to minus 1 over, and 1/3 squared is 1/9. We're losing the negative sign here. So now what we have is, what is this equal to? 1 over 9. Well, we basically have 1 divided by 1 over 9. And we covered this in a couple of videos already. Division by a fraction is the same as multiplication by its reciprocal. So that's equal to 9. And we can't throw over this negative. So the whole thing is minus 9. All right? So this might come up as you're computing. They may have an example with x squared times x to the 3rd times x to the minus 20 or something. And you have to figure some of these out. And they might say x equals minus 1/3 or something like that. And you have to apply that somehow to figure it out. Okay? And there's always a little twist to the examples. I'm trying to use the bite-sized concepts here, but something like this can get ugly real fast because you have to worry about the denominator, you have to worry about the reciprocal, and you have to worry about the sign altogether. All is 1. So let's just kind of end this by kind of combining some of the things. So if I have 1/69 to the minus 1/2, what is that as a percent? So we talked about this as 1 over 169 to the 1/2. We put it 1 over and we drop the sign. So the question is, what did this mean again? It means the square root. the square root of 169. Okay, and the square root of 169, I talked about knowing 11 times 11 up to 20 times 20. By the way, in the other video, I said 20 times 20 was 100. It's obviously I said it was 200. It's obviously 400. So in any event, the square root of this is 13. So we get 1 over 13. So now all we have to do is do that into percentage. So we have 13 goes into 1. 0, 0, let's see, 6 is 18, 1, that's 78, 70 is 91, I think, 1, 2, here we get 91, we end up with 9, 0, so 91 was no good, so we end up with 6, and so on. So we get basically 7.6%. All right. All right. So I'm going to end this there. I think we went 10 or 15 minutes. We went over on some of the other ones. Again, please like, subscribe, smash the buttons, and have a great day. And tomorrow morning, I'm going to do a larger one. We're going to do some of the more advanced questions on the SHSAT-like ISEE that I've been using. We're going to use the upper level one and start getting into harder problems. That upper level one is used for admission into high schools from grade 9 through 12, which is different than the other ones we used already. The lower one was basically grade 5, 6. The middle one is grade 7, 8. And the higher one is to get admissions into different high schools. Some of the questions are going to be harder than SHSAT questions, and some are going to be easier. So we're going to juggle back and forth as we're running through all this. All right, guys. Peace out. Everybody have a good day.